Hey, what's up, guys? This is Cheng here again. So today, daily challenge problem, right? Number 318, maximum product of word length. Okay, so you're given like a string of words, right? And you just need to return the maximum value of the product of two words, right? Where the two words do not have any common letters, right? If no such two words exist, return 0, right? Pretty straightforward, huh? Right? So basically we have like, for example, we have this kind of words list here, right? And in this, we have like 6 words here, and the answer is 16 because we have A, B, C, W, and this one. This two doesn't have any common letters, right? These two letters, because for the others, they all have some common letters. That's why the answer is 16, right? And then we have some constraints, right? So 1,000 and 1,000, and the letters are just the lowercase English letters, right? I mean, so this one it doesn't have any fancy solutions. Basically, we just need to check uh, all the pairs. We just need to check all the pairs of the words, and then we try to determine, right, if those two words have any common letter, right? So that's basically the idea here. But we can do some improvements on how can we check the common letters. I mean, the first solution will be what? So once we have two words, right, we just need to compare, right, to find if there's any letter. It's there are the same, and since uh we only will only have like possible 26 different letters, basically we can do what? We can for each of the words, right? We can have like a set or a dictionary where the set or the dictionary stores the appearances for the letter, right? And then once we have two words, basically we'll have like another for loop with 26 uh with 26 range at most, right? So basically we check each letter if the letter exists in both of the in both of the set or dictionary. If it does, then it means that okay, there's some common letters. Otherwise, we just keep doing until the end. Then we know okay, so there's no common letter for these two words, and then we can just calculate the product of the length, right? So for that, okay, let me try to quickly code that first solution. So for me, I can do the count here, right? And because I use like a dictionary, so in words, right? So we have a counter, right? Counter is going to be the counter of the word, and I just do a count dot append this counter. I mean, so the first one I just use for each of the word, I create like a dictionary for that word so that I can use it later. Then later on I just do this, right? And the length of words. And then we have for loop here, right? In range of n for j in range of n, right? So if the I does not equal to j, right? And then we have count 1 equals to the count of I, right? And then we have count 2 equals to count of j. And I'll also have like a flag find common, right? At the beginning, it's false, and then I have another like for loop, right? 26, right? Because we need to check each of the letters here, and then we have the character here is going to be the character of the ORD of the A, right? Plus K, right? That's how we enumerate each of the 26 English letters. So basically, if the CNT, if the count 1 dot C and count 2 dot C, count 2 C exist, right? Both exist, and then we know we find a common, and then then we set this one to true, and then we break from here. So if not find common, right, then we update the answer. The max of the answer dot length of the words, right? I times length of the words of j, right? So that's it, right? And then we just return the answer in the end. Cool. So if I run this one, it should just work, right? If I submit, cool. But as you guys can see, this first one is not that fast. So the reason being is because inside of a nested for loop here, we also have like a 26, another for loop with 26. So that's why this this solution here is like a n squared times 26, right? So that's the total time complexity. And so that's why I said we can do better here to not have to remove this for loop here. So for us to be able to remove the for loop here, we need to use like some bit mask, a bit manipulation trick here. So our target is to know if there's any common letter, right? In 2 words. Since we only have like 26 letters in total, right? That's why we can use like 26 length bit number to represent if we have if that value appears on that location, on that bits. So for example, we have right. So this is, let's say we have this kind of like a bit here, at the beginning. So we'll have like it doesn't really matter which way we're trying to use here, but let's say this is A. So for example, if we use the least significant bit as start A here, and then we have B, C, D, E, F, G, and H, right? So for each of the letter, for each of the word, we'll basically every time we'll look through each letter, and every time we see like a value here, we're gonna mark this one to 1, right? So for example, if this one is like 1 0 1 1 0 1 1 0, right? So if this is the word 1, right? And then we're gonna have like a word 2, right? Word 2 with some like different like bit value here. And all we need to do is we just need to do a word 1 bitwise and W2. Because if there's any common letter, it means that there will be both of the value will be 1 at that position. Then it means that this one will be not equals to 0, right? So if there's no common letter, it means that the end will always be 0. That's why as long as we have this kind of bit mask for each of the word here, instead of doing this for loop here, we can simply do end, and then we just need to check if the result is 0. If it's 0, it means that there's no common letter, right? Otherwise, we have common letter. And since there are like only 26 letters, so the biggest value in these numbers we can store is like 2 to the power of 26. So we can, at least in Python, this is like an acceptable number that the integer can represent, right? So yeah, so that's the improvement. And so to improve that, let's do I'm going to do a mask here, right? Let's make some quick changes here. So we have masks here, and then we have a mask, right? At the beginning 0, and then we have for C in the word, right? For each letter, we have the bit value is going to be a word of C, right? Minus the word of A, right? So that's the value. Then we just mark that value to be 1. We do this, right? Equals to, we do a bitwise OR, right? And then this one gonna be the bit. So basically here I'm converting this number, the letter, to its to the relative difference comparing to the A, right? Basically I'm converting this letter to a range of 0 to 25, right? And then we can use this one to find the location to mark the corresponding bit value, and to mark it to toggle it to 1, we do a bitwise OR, right? Cool. And then let's do a masks dot append mask, right? So now, so here it's going to be much simpler. So all we need to do is just this. Basically, we just need to check if the masks I, right, do an end of masks j is not equal to 0, and then we continue, or we can do this. Right? So we can do this. If this one is equal to 0, right, and then we update the answer, and yeah, I think that's it. If I run the code now, this one should. Oh, this one, yeah. Okay, cool. Submit. Yeah. So now this one is much faster, right? Because so for this one, it's like the it's O of n square, right? And or maybe plus some words here. They're like yeah, I think this one is O of n square. Yeah, that's why this one is faster. And yeah, that's pretty much right for this problem. Pretty straightforward, and with a little bit of a bit manipulation and a bit tricks here. And I'll just stop here then. All right. Thank you for watching this video, guys, and stay tuned. See you guys soon. Bye bye.